Since water is a molecule essential to all life forms, and especially important in defining the structure and composition of aquatic ecological communities, we need to spend a few moments reviewing its basic chemical and physical properties. The chemical formula for a water molecule is H2O, meaning there are two hydrogen atoms and one oxygen atom. These atoms are held together by a covalent bond. A covalent bond is one which connects atoms through the sharing of electrons. So in a water molecule, we have the two hydrogen atoms being connected to the oxygen atom through the sharing of electrons. In a water molecule, the electrons are actually not equally shared. The oxygen is hogging a little bit more of those electrons, and they're spending a little bit more time around that end of the molecule, which means that water ends up with two charges, a negative end of that molecule and a positive end to the molecule. This is referred to as a polar molecule, with having both a negative and a positive charge. Because of this polarity, water molecules are connected to each other. You have one water molecule's positive end connecting to the negative end, and this bond is referred to as a hydrogen bond. So hydrogen bonds connect one water molecule to another. So bonds formed between water molecules due to the attraction between the negative end or oxygen end of one water molecule and the positive end or hydrogen end of another water molecule. As a result of these chemical bonds, water has a number of distinctive chemical and physical properties. So as a result of the covalent bonds, water has polarity. As a result of its polarity, water is considered a universal solvent. It has both a negative and a positive charge, so it's very good at dissolving a large number of other chemical molecules. As a result of its polarity, water also acquires the property of cohesion, which really is the result of the hydrogen bonds connecting one water molecule to another. That stickiness between water molecules leads to a whole suite of other physical properties, including surface tension, viscosity, density, as well as a high specific heat capacity. The definition of cohesion is the act or property of molecules of the same element sticking together, as opposed to adhesion, which refers to molecules sticking to different molecules. Water molecules are attracted to each other due to water molecules' polarity. This attraction between water molecules results in the hydrogen bonds forming and water's cohesive chemical properties. Surface tension refers to differences in attraction among water molecules between the surface of the water and the air. The lower kinetic energy of liquid water molecules increases the attractive forces of the hydrogen bonds, and then causes there to be this sharp boundary at the liquid-air interface. Viscosity is also related to the attractive forces of these hydrogen bonds. Viscosity is a measurement of the force that is actually necessary to separate the molecules apart, essentially break those hydrogen bonds. The frictional resistance of water is about 100 times greater than air, so it gives you a little sense of how much force is needed to break those hydrogen bonds. Hydrogen bonds also play an important role in driving water's high specific heat capacity. So specific heat is how much energy is required to heat a substance. Temperature is a measurement of movement or kinetic energy. Before a water molecule can start moving, the hydrogen bonds need to be broken. So it's relatively hard to make water molecules move fast because its hydrogen bonds keep the molecule stuck together. Water's unusual density properties are affected by the physical configurations of these hydrogen bonds. When the kinetic energy of water decreases, which we measure via temperature, down to the point where it's forming a solid, the hydrogen bonds have to become arranged in this very specific configuration to accommodate all the oxygen and hydrogen connections between a multitude of different water molecules. This hexagon configuration is familiar to us in the crystal-like patterns of snowflakes and ice. So water actually becomes less dense as it forms into a solid and is actually most dense at 4 degrees Celsius right before it's a liquid and right before it freezes into that solid particle. This is very significant for ecology, that water becomes less dense as it converts to a liquid to a solid. It allows ice to float, which therefore allows for the insulation of water bodies, and they don't freeze solid. This is huge for aquatic communities. You can imagine a very different set of biota if lakes froze over completely every year and didn't have liquid water underneath. So just to review here, the chemical bonds that hold water together and connect water molecules to each other, those covalent and hydrogen bonds, have very significant influences on the chemical properties and physical properties of water, and those properties have been very significant for all forms of life on the planet and therefore critical to our study of ecology.